Good morning, Shakti. How are you? How things are going? Okay, confident now? Okay, good. See, normally what happens whenever there is exam, no matter how prepared you are, you will be nervous. Okay, and it's a natural process. Nobody likes to be put under pressure, or nobody likes to be judged. Okay, so exam is that kind of a process. So nervousness will be there always. So what we have to do is we don't have to get too much tense. The reason being, now whatever we could have prepared, we have done. Okay, whatever was in our hand, that we have done. So now we should not be thinking much about that. Oh my God, that we could have done, that could have nothing is possible. Why? Because whatever the time was available, whatever things were available, we have done to them. So you should be happy that I have done from my side. Okay, you should not think about the result. The result is not in our hand. Okay, because the result depends on competition. There are many people who are doing it. So that all depends on competition. What you should be happy with is whatever I have done, I am happy with that. Because that's in our hand. Alright. Result is in hand of God. God is going to decide what is going to be the result. And believe me, if suppose we are truthful to us, okay, we are honest, we have done honest preparation, then God is going to do bad with us. Okay. So God will take care of that. So we should not be thinking too much about the result because that's not in our hand. What's in our hand is our preparation, how better prepared we are, okay, how much work we have done. That much only is in our hand. So forget about the result. We are tense mostly because of what? We are tense because of the result. When we think too much about the result, we should not. This is what we have to do. Keep doing. And in doing that, there is no tension. So forget about the result and keep doing what is in our hand. Okay, keep following the process. Process is preparation. Whatever is there, keep preparing. Keep revising. Because revising is one thing which will make you remember all the things. So small things are there, small topics are there, small notes you have made. So those notes keep revising. Don't go for those things which we have not studied, not required. Okay, that is when you start getting tension. Oh my God, this is also we have to do, that is also there, that is also there. No need. Focus on small notes which gives you enough knowledge about the entire topic, that only you concentrate on. Don't concentrate or don't think about certain tough things which actually are not ours in NEET exam mode. Okay. Your focus should be in last 4-5 years question papers at the most. Nothing more than that. Okay. So try and avoid thinking about result and getting tension. Remember that. Is it clear? Is it clear, both of you? Shakti and Shweta, is it clear?
Yes, sir.
Okay. Sorry. Let's start. Big topic I have taken. I thought first we'll be doing about magnetism and matter, but when I saw that it's very small topic, so I thought that let's start with the big topic. Magnetism and matter we'll do along with other small topics like electromagnetic waves is there, and logic gates a little bit we have to discuss. Then along with that we'll discuss the magnetism and matter. So this is a very big topic, and one day is not enough for that, right? So let's start ray optics. Ray optics means is what we are going to study about light. Okay, study about light. Study about light. How light is coming, what object is there, which are producing light, image, everything we study under that, right? And the first thing that we study in this one is reflection. We all know what reflection is, so I'm not going into that. Directly, we are going to talk about laws of reflection. The laws of reflection also we know, but let's just recollect it. What we say is incident ray, normal, and reflected ray. And reflected ray all are in same plane. All are in same plane. Okay, same plane. Same plane means what? If suppose that we are going to make a mirror, okay, mirror is this, right? And this one, okay, this is the mirror. And we make incident ray. This is the incident ray. Okay, then make a normal here. Normal we'll make with dotted lines. Okay, so this is normal. Okay, and then reflected ray also we are making. So here is reflected ray. Okay, something like this. So all three are lying in same plane. So if I say this is x-axis and this is y-axis, then all three are lying in which plane? XY plane. This is an XY plane, this is y-axis itself, and this is also an XY plane. So all three are in same plane. Okay, that is the meaning of laws of reflection of the first law. Second law, we all are aware about that. What it says is angle of incidence is equal to angle of reflection is equal to angle of reflection. Angle of incidence is angle made by incident ray with a normal. So this is angle of incidence and this is angle of reflection. So I is equal to R. Okay. This is called glancing angle. So remember, sometimes they ask you about glancing angle. So this is glancing angle. Okay. The glancing angle of incidence is also equal to glancing angle of reflection. Okay. So this is what laws of reflection are. Fine. Then we have plane mirror. Now reflection, actually there are two types, we know that. Okay. Normal reflection that we talk and diffuse reflection that we talk. So diffuse reflection means is one is from abnormal surface and the normal reflection will be from plane mirror. But in both the cases we will have reflection will be followed. Okay. So plane mirror means what? Smooth surface. Smooth surface, we call this as a plane mirror. Right. So what we have to do with plane mirror, we have to understand certain things. What? First of all, what is called image? Okay, we need to discuss about image first. So for that, let's move this one first forward. Plane mirror. Okay, or this one I'll remove it, not required. Image and object. What is object first? When we are talking about light, that means we are talking about objects and images. What is object? Okay, so object means is from where we will be seeing that the incident rays are diverging. Okay, incident rays diverge from here. Incident rays diverge from here. Always, yes, if it is a real object. Okay, when we talk about virtual object, incident rays appear to diverge, you can say, or incident rays appear to merge, okay, or to meet at that point. Incident rays appear to diverge or incident rays appear to meet at this point. Incident rays appear to meet. Now, how that is, we will see that. Okay, so if this is a plane mirror here, okay, this is plane mirror, and on this line I am going to keep the object. So if this is real object, right? So from here incident rays will be diverging. So it will be going like that. This is incident ray. Okay, and one more we will make. In all the directions these are going like that. So I am just making two. Okay, so these are the incident rays which are diverging. Incident rays. So this object is what? Real object. This is real object. Okay. Now at the same time, now virtual object also we have to discuss. Okay. This is actually appear to meet is I am talking about virtual object. Now how is the virtual object? See. This is mirror here. Okay. So this is mirror and this will continue here. This line will continue. Right. Now in this one what is happening? In this one the incident rays are actually coming from somewhere. They are coming from somewhere like this. It's coming like this, and one more we will make. So incident rays are actually converging somewhere. Right. But in between plane mirror has come. Or mirror has come. So then what to do? Now we are going to take them forward. Okay. We are going to take them forward here. We'll say that okay, these are appearing to be coming from here. Right. They are appearing to be meeting at this point. Okay, like this. So when incident rays appear to meet at this point, this we call as virtual object. This is virtual object. Clear, we are talking only about object. This is real object from where incident rays are actually diverging. Okay. And here incident rays, these are incident rays, okay. These are incident rays. So incident rays here are appearing to meet on the other side of plane mirror. We are calling it as virtual object. Behind the plane mirror, we are calling it as virtual object. Okay. So this is how we define objects. Okay. Then we have images also. Images how to define. So images or image also real object, real image and virtual image. So real image means what? Where reflected rays actually are meeting. Okay, real image. Where reflected rays actually meet. Actually meet. Okay, second one virtual. Where reflected rays appear to meet. Where reflected rays appear to meet. Okay, both we'll see. Right, again plane mirror. And this is plane mirror for us, or we'll make it here. This is plane mirror. Okay, and this is the axis we are making. Right, now reflected rays we are talking. So reflected rays, first we have to talk about incident rays, then only the reflected rays will happen, right? So how are the incident rays? I want to know the real image. So incident rays are like this. Okay, these are incident rays. Same way, one more. Okay, right. Now they are getting reflected from here. Here normal is there. Make normal. This is normal here. Okay, and we will make normal below also. So here is below normal. Okay, both normals are ready. Now what will happen? Reflected rays will be there. So reflected rays when you are making will be like this. Okay, all right. Like this it is. And here also. Right. And this is reflected rays. Now you can see that this is incident rays and this is reflected rays. So reflected rays are actually meeting here. This is real image. This is real image, but where is object? This is for virtual object. This is this diagram, right? Here I didn't show you reflected rays. Here only I showed you object. Okay. So where exactly in this one incident rays are meeting? Meeting point of incident rays is where? On the back side. So that's virtual object. Be somewhere here. Okay. This is virtual object for you. And this is real image. Clear? Real image. Now let's talk about virtual image. Now virtual image is what now? Virtual image is this. So little clarity is required, nothing much in that, okay. So this is virtual image, this is your axis. Okay. Now this time we are going to take one real object here. From real object, we'll take incident rays. This is one incident ray. Okay, another one we will take. Right, these two are incident rays. Now reflected ray will be there. Where reflected ray are going? But before that, let's make the normal here. Normal is here. So this is normal. Okay, one more here. Okay, then reflected rays. How will be the reflected ray? Reflected ray will be obviously going like this here. Okay, we're going like that. And here also same way. Okay, going like that. Then where is the image? Image is made by reflected ray, not by incident ray. So remember that this is incident ray and this is reflected ray. So reflected ray, how to take? It appears to be meeting at some point. It appears. So it will be meeting where? On the other side. Okay, so this is the image. This is virtual image. Okay, this is virtual image. So what we have learned from this ray diagram, it says that for real object, plane mirror makes virtual image. For real object, you are getting, for real image, you have virtual object. Okay, if you want real image, object is virtual. And if you want virtual image, then object is real. So for virtual image, object is real. Okay, for real image, object is virtual. For virtual image, object is real. Okay, this is what we learned from plane mirror. Few more things we learned from plane mirror. It says that, however, whatever is the distance of object from the mirror, same is the image distance. Okay, if this is x, we'll make it with a different color, right? If that is x, then image distance is also x1. In both the cases, yes, here also. If this is something like y, this is also y. Okay, one more thing is what? The size of image will be same as size of object. Okay, size of image is equal to size of object. Specialities of mirror. Okay, clear? Then what we have here, we have curved mirrors after this. So this is plane mirrors basic information. Object distance equal to image distance, size of image equal to size of object, and if suppose that an object is kept on 45-degree with axis, then a horizontal object's image will be vertical, or a vertical object's image will be horizontal. We will see that if possible in ray diagram, we will see that also. Okay. Now what? We have curved mirrors. So curved mirrors are carved out from sphere. So this is a sphere. Okay, and from the sphere we are cutting out two mirrors. One is like this here. Okay, and another one is here. Right. So we are cutting it. One is this, and we are polishing. We have polished it like this, and we have polished it like this. So this is becoming convex mirror for us. We have polished it inside of the sphere. We are calling it as convex, and here we polish outside. We are calling it as concave. Okay. Now this is center of curvature here. Center of the sphere, we call it as center of curvature. Okay. So this is radius. See, this is radius. This is called radius of curvature. So see center of curvature. R radius of curvature. Focal length. Focal length F. F is equal to R by 2. F is equal to R by 2. Okay. Then what else is there? Now we can decide that whether the focal length is positive, negative. What is focal length basically? What is focus? The focus is defined as if the incident rays are parallel to principal axis. Okay, then rays will be converging at focus. Okay, focal length, the definition is what? If incident rays are parallel to principal axis, then after reflection, rays will meet at focus. Rays will meet at focus. Okay, principal axis means what? A straight line which joins center of curvature and pole of the mirror, or optical center of the mirror. Okay, this is principal axis. This is pole of mirror. Okay, and this is what? Principal axis. Okay, this principal axis. Okay, then after this is what? After this is relation. Okay, mirror formula. Okay, what is mirror formula? Mirror formula we'll have here. Yeah, mirror formula is there. So ray diagram. Fine. So incident rays are parallel. We got focal length. We got relation between focal length and radius of curvature. Okay, F is equal to R by 2. This is convex, this is concave. Now I'll discuss about whose focal length is positive, whose focal length is negative. So what is the convention? What is the sign convention? The sign convention here says what? What is our sign convention? Sign convention is very simple. Follow the light. Distance measured in the direction of light is positive, distance measured in opposite direction to light are negative. Distance is measured in the direction of light. In the direction of light are positive. And opposite to it are negative. Opposite to it are negative. Okay, and distance is measured above principal axis are positive, below principal axis are negative. Okay, so this may be point number 1. Point number 2, distance is above principal axis. Above principal axis are positive. Are positive. And below are negative. And below are negative. Okay, these are the sign conventions. Okay, then ray diagrams. Are we going to make ray diagrams? No, we will not make, because it takes a lot of time. So ray diagrams, what are the important things about ray diagram? You should remember. Those all I am writing. Okay. So what is that? We all know that if object is at infinity. Okay. If object is at infinity, or conventions of ray diagram also we should write first. So I'll write convention of ray diagram first. If incident ray is parallel to principal axis. Parallel to principal axis. Then after reflection, it passes through focus. After reflection, it passes through focus. Okay, point number 1. Then point number 2, if a ray is passing through center of curvature, if a ray passes through center of curvature, it retraces its path. It retraces its path. Okay, then third one. What is third here? The third one is if a ray is passing through focus, it will become parallel to principal axis after reflection. If ray, now almost same will be there for lenses also, except this. Okay, if ray passes through focus, reflected ray become parallel to principal axis. Okay, becomes parallel to principal axis. The last one, if ray is incident at pole of mirrors, then what happens? Simple laws of reflection will make, and there are no specific points about which it has to pass. Okay. So if ray is incident at pole of mirror, according to law of reflection, according to laws of reflection, reflected rays is drawn. Okay, nothing special in that. These are the conventions of ray diagram. Now, whatever the ray diagrams are there. Okay, conclusions I am writing. What are the conclusions? Now, conclusion for which one? For convex mirror or concave mirror? So first, we will talk about concave mirror. Concave mirror. Now, concave mirror's focal length is what, first of all? How is concave mirror? Let's say concave mirror is like this for us. Is our concave. Okay, then how the light is coming? The light is coming from left to right. This is light. Okay. So that means this direction, whatever we are measuring towards positive x-axis will be positive, and whatever we are measuring along negative x-axis will be negative. Okay. So first thing is here, when we are going to keep object we are keeping at infinity, where is minus this side. So minus infinity. Okay. What about the focal length of this? Its radius of curvature will be somewhere here. This is center of curvature, this is radius of curvature. The focus is here. And this is called origin for us. That's O. So when I am going to measure the focal length of this, then I have to come this side because this is 0. I have to come opposite to the direction of light. So focal length of concave mirror is negative. Okay. Focal length of concave mirror is negative. F is negative. Always negative. Yes, always negative. Whether you make like this, above, below, anywhere you make, its focal length is negative, means negative. Okay. Radius of curvature, negative. Okay. Now, since we are keeping object here, this side, we are writing it as U is negative. U is negative infinity. So, we know that V is what? V is minus. Here will be the image. So, V will be minus. Okay. Second, U equal to, where we are keeping it? At center of curvature we are keeping. No, between center and focus, center and infinity. Okay. So, then, so infinity, okay, is greater than U, which is greater than radius of curvature. All are negative, okay. All are negatives. One here, here, and this is also negative, obviously. So somewhere here. So it's beyond C. So if beyond C, then image will form where? Between F and C. Okay, image will be where? Between F and C. Okay, so minus C or minus R greater than V, which is greater than minus F. Okay, so when it is between C and infinity, here, this side, then image will be between F and C. Correct. Then third one we will have when object is kept at C, that is U equal to minus R. So when U is equal to minus R, V is also minus R. Correct. Then when the object is between C and F, for this object is between C and F, so minus R greater than U is greater than minus R. U is between center of curvature and focus. Then what will happen? The image will be beyond C, between C and infinity. Okay. So minus infinity greater than V is greater than minus R. Okay. So when object is over here, image is here. When object was here, image was here. Now object is here, image is here. Then finally, fifth one, U equal to minus F. U equal to minus F. So V equal to minus F. Then final one, sixth one, when you have object between focus and pole, right? Sixth one, when U is less than minus F, then what will happen? Image is virtual, we know that image is virtual. Okay, image is going to be virtual here and magnified or diminished. Magnified, bigger image will be there. Okay, so V, what shall we write V? Hmm? It depends on the value, but this is virtual. Virtual image. And one thing we can write is V will be greater than U. Okay, V will be greater than U. V's magnitude will be greater than U's magnitude because it will be magnified. So these are the informations as far as concave mirror we should remember. It's necessary. Okay, then convex. Convex, we don't have much to be remembered as such. Not much, right? So where we'll do this ray diagram actually, we rather mirror formula. Just remove it here, and then here we are going to do for convex. For convex, what we remember? Okay, convex is like this, right? This is your principal axis. Then radius of curvature is here. This is R, and here is focus, because focus is half of radius of curvature. The light is coming from this side, so focal length is always positive. So as radius of curvature, both are positive in this one, right? So if we are going to make the object is at minus infinity. Object is this side, and where will be image? Image will be forming here on the other side of the mirror. That means this is a virtual image. Okay, definitely V is F only. We will form it F, but this is a virtual image. And remember, convex mirror always make virtual image of real object. Always virtual image of real object. Virtual image of real object. Then object diminished, always diminished image. Virtual image is okay, but always diminished image also. At that point also we'll write. Always make diminished image. Diminished image. Okay. So use minus infinity V equal to F. Now any other point. Now any other point means, because here there is nothing, like we cannot say radius of curvature or focus or anything over here. Here infinity was okay, but second is we know this is pole of the mirror. Other than that, we don't have anything. Okay. So anywhere you keep, what is going to happen? The image will be obviously smaller than the object. That is for sure. Okay, so V will be always less than U. Okay, anyway, anywhere you keep, V will always be less than U for convex mirror. Okay, now we are going for mirror formula. What is mirror formula? Is it applicable for both? Yes, we know that. So mirror formula is 1 by F equal to 1 by V plus 1 by U. 1 by V plus 1 by U. This is mirror formula, and we have to take sign convention while following it. That's why we said that F of concave mirror is negative, F of convex mirror is positive, and if the object is on the left side of this one and is opposite to the light is negative, and image also, if it's in the direction of light, positive, otherwise it's negative. So mirror formula is 1 by F equal to 1 by V plus 1 by U. Okay, then magnification. Magnification is what? Magnification is minus V by U. But what magnification actually meaning? Magnification actually meaning is height of image by height of object. Minus V by U. Okay, clear? Now we need to understand In which case, what is the magnification? Suppose we are going to talk about we have real image and real object. Then what is magnification actually? It's positive or negative. So for real image, for real object first, okay? Real object, real image. And what is magnification? Let's see. So real object means is what? On the left side. On the left side means use negative. On the left side use negative. Real image means V is also negative. Okay, let's see. Okay. When you talk about real object means here, this side. Real image means that is also this side. So that means both are opposite to the line. So U is also negative, V is also negative. U is negative, V is negative. So that means magnification will be negative. Second, for real object virtual image, let's see. So real object means minus U and virtual image means V is positive because virtual means on the other side of the mirror. That means along the line. This is positive, this is negative. So negative, negative. Same as positive. For real image, virtual object, for real object. For real object here and virtual image, right? For real object, both we have seen. Now let's go for virtual object. Okay. So for virtual object and real image. Normally virtual object questions are not asked, rarely asked. Okay. Maximum questions will be on real object. Okay. Virtual object, real image. Now what is the magnification? So when we talk about virtual object, that means U is positive. U is positive. And image is real. That means image is negative. That means V is negative, U is positive. So negative, negative again. So positive. Fourth one, virtual object, virtual image. Nobody is going to ask you about this, but at least we should have a clarity, right? So what is magnification of this? So in this one, both are virtual. That means U and positive, V is also positive. So magnification is still negative. So this is how we decide whether the magnification is negative or positive. Okay. Now I have framed certain questions for you so that it becomes very clear to you that what type of mirror is there, what type of magnification is there, which is correspond to particular type of mirror. Okay. All right. So what's given here? Magnification is given. Minus 0.6. For which one? Here we have clearly mentioned that this is for real object. What we have to find, which type of mirror is there. So real object is there. Object is real. Magnification is coming minus. Okay. So when it is possible? When image is real. See? A real object, real image. Magnification negative. He is saying magnification negative. So what it is? Real object. Real object already given. Real image. This is possible real image only. So image is real. Is it for concave mirror or convex? Convex makes never a real image for real object. It doesn't make it. So that means this is concave only. Okay. So which mirror this is? Concave. Okay. Convex mirror always makes virtual image of real object. So that's why there is no chance of convex here. Clear? Negative is there. Negative means is for real object it has to be real image. The real image is made by only by concave. Okay. Next one. Again one more negative is there. Is a minus 1.5. Minus 1.5 when we have magnification is more than 1. It means large size of image is there. Magnified image is there. Okay. that we can write over here. If m is greater than 1, minus plus anything, okay, it's a magnified image. It's magnified image. And if m is less than 1, diminished image. This is diminished image. Okay. So here it is. This is magnified image. Okay, minus it is again real object. So that means image is real. Real image. Magnified image. Which way are possible? Concave only. So concave makes diminished image also and magnified image also. Concave mirror is making diminished image also and magnified image also. Fine. Now what is there? M equal to plus 0.8. Real object. For real object, magnification is coming plus. When it's possible, has to be virtual image. Has to be virtual image. Now 0.8. 0.8 means is diminished image. Now do concave makes diminished image virtual? Concave makes virtual image. But does it make diminished? Answer is no. It makes magnified image. So this is not concave. Then what it is? Convex. This is convex mirror. Okay. Then m is equal to plus 1. One more time plus. Image is virtual. Image is virtual. Image is virtual means convex. But convex always make diminished image. This is of the same size. Not possible. Concave always make larger image. So concave not possible. Then what is this? This is plane mirror. Okay. So see, I explained you everything. Right. Negative, diminished image, real. Negative, enlarged image, real. One more thing I could have done. I could have made here one more. Fifth one. M equal to plus 1.5. Okay. So when you have M equal to plus 1.5, then what we will say, plus is there means virtual image is this. But you can see that this is more than one, that means magnified image. Magnified image, virtual image, who makes it? Concave. So here is concave. Okay. So like this, we should have a clarity that what kind of magnification, when we have to use negative, when is positive, everything we should have clarity. Okay. Right. So let's use them now. Let's use them whatever we have done in numerical and see whether we can do it or not. Right. Okay. Let's solve it. So what's given? Radius of curvature is given 24 centimeters. Convex mirror it is. So first is make the diagram of convex mirror. Before solving, just make it to give you better idea that what are we going to do. The radius of curvature 24 this side, that means positive. So focus is here. So we'll say okay, focus 24 by 2, that is 12 centimeter, and it's positive. Okay, then U is 8 centimeter. U is 8 centimeter, and obviously we are talking about real object. Okay, what is asked? What is V, what is M, and what is nature of it? Okay, fine. Okay, so U is 8, U is here. Here is object. Okay, this is 8. Fine, how to do? 1 by F equal to 1 by V plus 1 by U as the formula. Put along with the sign convention. This is positive, so 1 by 12. V we do not know, so no sign convention. U value is 8 centimeter. And is it along the light? From where light is coming? Like this, because object only is going to produce the light. Light is like this. So object distance from origin, you are coming opposite to the direction of light. So object distance negative. So minus 1 by 8. Bring it this side. 1 by 12 plus 1 by 8 equal to 1 by V. This is here. 12 and 8, this will be 24. This is 2, this is 3. So V is 24 by 5 centimeter. 24 by 5 centimeter. Okay, now what? Magnification. What type of magnification? We know it has to be positive with the virtual image. It's a virtual image. What is magnification? Minus V by U. Right. So this is minus here as it is, 24 by 5. It's positive. Positive means this side. This side. Virtual image. And U is what? Minus 8. So it's positive. You can see that. What is magnification? 3 by 5. Or you can say plus 0.6. Correct? No doubt about that. Then nature of image. We said it's a virtual image. Magnification plus 0.6. Clear? Done. Everything we have done. Next one. Next one we have concave mirror. Radius of curvature given 20. Height of object is 5. U is 1 meter. And is asking height of image. So concave mirror. This is concave. Right. So this is radius of curvature here. And here will be focus. Right. And light will be going like this. So focal length is negative. We said already that focal length is always negative. And how much is that? R by 2. That means focal length is minus 10. U value 1 meter, that means 100 centimeter. Where? Left side. So U is also negative. Okay, let's find out V first. So 1 by F equal to 1 by V plus 1 by U. So minus 1 by 10, 1 by V, minus 1 by 100. This will come over here. Minus 1 by 10 plus 1 by 100 equal to 1 by V. This is 100 here. Minus 10 plus 1 equal to 1 by V. So V is coming as minus 100 by 9 centimeters. So V is also on the left side. It's a real image. It's a real image. Okay. We know that one. It's a real image. So for real image, what should be the magnification? Negative 1. Magnification will be negative 1. Right? Okay. Because magnification is minus V by U, so it will be negative. So what is magnification? HI by HO. Okay. So what is there? V by U we have to write. So minus 100 by 9 by minus 100. So as I said, it will be negative only. So this and this gets cancelled. So HI by HO is minus 1 by 9. Now, what is HO? Say 5. So HI is 5. Oh, sorry, HO is 5. HI by 5 equal to minus 1 by 9. So HI is minus 5 by 9. So what this minus is indicating as, it is actually inverted image. That means below the principal axis. Object will be something like this. It's 5 centimeter. Image is something down. Okay. Image is somewhere down. Where it is, this is 10, right? Focal length, and this is coming 100 by 9. Okay. So here's this is image. So that's why it is coming minus 5 by 9 centimeters. Here it is simple. Then again convex mirror, focal length is f, and it is given that height of image is 1 by n times height of object. So HI by HO is actually 1 by n. That means magnification is given, no? HI by HO is only called magnification, and that's value is given 1 by n. Which mirror? Convex. What we know about convex? It always makes virtual image. That means magnification is positive. Alright, focal length is f, u. We have to find u value. So magnification is there, and we have to use our mirror formula. Convex mirror means focal length positive. Okay, u only will be negative for us for real object. Hi by HO, that is magnification, is 1 by n. So 1 by n is okay, but this should be equal to minus V by U only. Yeah, magnification is minus V by U only. No doubt about that. Okay, let it be there only. Now we are talking about this 1 by F equal to 1 by V plus 1 by U. So this is 1 by F as it is. U will be negative for real object. Okay, bring it this side. It's 1 by F plus 1 by U equal to 1 by V. So what we have, this is U plus F by Fu equal to 1 by V. That is V equal to Fu by F plus. Shall we place it over here? Place it. Okay. So what we have here, 1 by N. Okay. Minus Fu by F plus U by minus U. Sign convention. Okay. So minus minus gets cancelled, U and U gets cancelled. So 1 by N equal to F by F plus U. What we have, NF equal to F plus U. So what is U here? F you take here, this is N minus 1 equal to U. Okay, U equal to F into N minus 1. Clear? Here it is. Okay, so you ask what? U only, no? U in terms of F. So F is F into N minus 1. That is the value of U. Right? So this way we have to do. If he is giving in terms of magnification also, no problem to us. There is no issues. Okay. Alright, let's go ahead. What's given there? This is concave mirror. Its focal length is 15 centimeter. Object distance is 30, but object is not standing perpendicular to principal axis. It's lying on principal axis. Its size is 5 centimeter. So we have to find size of it. Now what we have to do in this case? We are going to consider one object is here and another object is here. And we are going to find their images. Okay. What is the image of object number 1 and what is the image of object number 2? Then we will think about what is the size of image. What is size of object here? Object position of this and object position of this, difference between the two is size of object. Okay, if I say this is U1 and this is U. So what is the size of object? Say U2 minus U1. Correct? Same way size of image also here will be difference between the position of images on. Okay. So in this case first, when we are solving it, we are writing U1 is minus 30 centimeter and U2 is minus 35 centimeter. Now when you look at this one, its focal length is given 15, so that means its radius of curvature will be what? 30 centimeter and minus 30 centimeter, because it's opposite to the direction of light. Light is like this. So that means U1 is on radius of curvature or center of curvature. So V1 is going to be same, minus 30. So we don't have to calculate it. That much we have information already. So only V2 I have to calculate. Answer is yes. So we will calculate only V2. So V2, 1 by F equal to 1 by V2 plus 1 by U2. Normal formula. Okay. Let's put the value according to sign convention now. Minus 1 by 15 equal to 1 by V2 minus 1 by 35. Now we are going to get V2 from here. Minus 1 by 15 plus 1 by 35 equal to, its LCM is going to be what? I think 105. So 105 is the LCM. This will be minus 7. This will be plus 3 equal to 1 by V2. So V2 is coming minus 105 by 4. So V2 is what? This is 4 2 ja 8 and 4 6 ja. Okay. 0.10, then something like this. So what is he's asking? What size of image? So size of image is what difference between these two only. Size of image is -30 minus 26.25. That's 3.75. There's the size of image. Okay, this will be the size of image in this case. So in this case, what we have to do, we have to consider two objects, we find two images, and then from there we'll be able to get the size of image. Okay. All right. Convex mirror again this time. Magnification given 1/3. Convex mirror is there, we know magnification is positive. Find u in terms of focal length. All right. So m is 1/3, which is minus v by u. It's 1/3 equal to minus v by u. Fine. Okay. Then what we have? Mirror formula is 1/f equal to 1/v plus 1/u. Okay. What we'll do? Either you find v from here or find u. That's your wish. So object is real. So 1/f plus 1/u equal to 1/v. Because object we are taking as real object, so u will be negative. We brought it over here. Then what again? Be u plus f by fu equal to v equal to fu by f plus. I'm going to put in this one. So this is 1/3. Okay. Minus fu by f plus u, and this is negative. Okay, this is cancelled. This u is cancelled. So what we have here? F plus u equal to 3f. What we have to do? U in terms of focal length. So u is 2f. U value is 2f. That's all. Okay. So this way we can find out the magnification problems we can do easily, right? Concave mirror. Concave mirror's focal length is 15, magnification is given 3. Find u if image is real. Okay. All right. What solution says? Solution says that it's a real image. So real image means magnification will be negative, right? And what they want? Nothing as such. Okay. Fine. So magnification is minus v by u, and it's real as the image is real. So this will be minus 3 equal to minus v. So v equal to 3u, right? Okay. Now what? Focal length is given to us. So 1/f to 1/v plus 1/u. Okay. Here concave is there, so minus 1/f. And this will always be negative, so bring it here. This is plus 1/u equal to 1/v. Same thing I am doing. Whenever this v by u is there, no, I am doing same thing. No change. Okay. So what we are getting here? Minus u plus f by fu equal to 1/v. So v equal to minus fu by f minus u. Place it here. Okay. So this is 3 equal to v value minus fu by f minus. What about u? What is u? Negative. So then this is cancelled. U is also cancelled. What we have now? 3f equal to f minus u. Okay. 3f equal to f minus u. That's all. Okay, use minus 2. I think we have done some mistake here. Mistake is here. Because if u is minus 2f means u is at radius of curvature only, then it it will be of the same size. Okay, I need to check where I have done any mistake is there. Here minus 1 by f, this I have taken equal to 1 by v minus u plus f by f2 equal to 1 by v equal to minus f2 by f minus u. Then it's minus v by u, so minus minus gets cancelled. 3 equal to minus f2 by f minus u, and this is u. So this is here f by f minus u. So 3, yeah, this is wrong. Multiplication I did wrong. Okay, 3 equal to f by f minus u. So this is 3f minus 3u equal to f. Okay, so this 3f goes that side. It's minus 3u equal to minus 2f. So u basically is 2f by 3. Okay, let's check the previous cases also if I have done anything wrong. Okay, f by f, as you know, this is correct. Okay, here only I did the multiplication wrong. So u is equal to 2f by 3. Okay, alright, then focal length of mirror does not depend on medium. Yes, absolutely, because focal length of mirror is r by 2. Okay, so it depends only on radius of curvature and it doesn't depend on anything. Forget about medium. If the question says that mirror is kept inside water, it's kept inside the glass, it's kept inside this, that, focal length will be same only, no change. Okay, alright. Now let's talk about graphs. Very, very important. Okay, because from the graphs, questions are asked. Okay, so first graph what we will be making? 1 by v, 1 by u graph. Okay, 1 by v, 1 by u. So here is 1 by v, is 1 by u. Okay, and this graph, yes, I can move it. You can bring it down here. Okay, we can't move. All right. Okay, fine. So 1 by v, 1 by u graph is here. For which mirror we are making first? Let's say we are making for convex. What we know about convex is focal length is positive. So 1 by f equal to 1 by v plus 1 by u. This is the formula. But here we have made this is along y-axis, this is along x-axis. So equation I want in terms of y equal to mx plus c. Okay. So what is y here? 1 by v. So 1 by v equal to 1 by f minus 1 by u. Okay. Now if 1 by u is 0, what is 1 by v value? So 1 by f. So 1 by u is 0. That means here 1 by v value is 1 by u. Same way when 1 by v is 0, 1 by v is 0. Then what is 1 by f value? So plus 1 by f. So this is also 1 by f. Again see, when 1 by u is 0, 1 by v value is 1 by f. When 1 by v is 0, 1 by u value is what? 1 by f. Now join them. This is only the graph. Oh God, a line is not passing through that. Yes, this is the graph. Okay, this is the graph here. Okay, now concave. Do it concave here. Okay. Same one again, one more time. Okay, this is one and this is other one. 1 by V, 1 by U. Okay, now for concave, what is there? Its focal length is negative. 1 by F equal to 1 by V plus 1 by U. So put here negative. V and U, we are not doing anything, only focal length is negative because V and U can be positive, negative, all others. So we don't have to give sign over here. So 1 by V is what? 1 by V is here. This U will be coming. So minus 1 by F minus 1 by U. Now check. If 1 by U is 0, what is 1 by V value? It's a minus 1 by F. So that means here. Okay. Now if 1 by V is 0, what is 1 by U value? Again minus 1 by F. Minus 1 by F means here. This is minus 1 by F. Now we have to join these two. That's all. Have to join these two here. Something like this. Okay, this is the graph. So 1 by V, 1 by U for convex, 1 by V, 1 by U for concave. This is the graph. Okay. Right. Then UV graph. UV graph also we should see. Okay. This is V. This is U. Now for what we are making here first? Okay. Let's see convex first. Now convex focal length is positive. Okay. So convex focal length is positive, and do we have image also forms at focus and object also can be kept at focus? Yes. So we'll mark it out. For U also positive F, one line. Okay, because this is, remember, this is your pole origin. This is what? Positive F. Same way along V also make one line for positive F, because your focus is positive. Okay, this is also positive. Now you see that there are 4 sections over here. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now this is convex. So what is the smallest section in the convex over here? This one. Because virtual image you have to make. In convex, what type of images we have? Virtual, no? Most of the time. V positive, U, okay, V positive. So here will be the smaller section. Now what I am telling you is a shortcut I am telling you. Okay, you should be able to make the shortcut over here now, because we are not able to trace out the images and object, and we are not going to do it directly, we are going to make it. Okay, so this is how it is. We'll check it, we have done correct or not. So this is how it is. Okay, now when you are going to have object at negative infinity, then where will be image? You say positive F. Negative infinity means this side. Image will be at positive F. Okay, positive F means this. Correct. When you have object at pole, then image will be forming at pole only. There is no doubt about that. Okay. Then when you are going to keep object at focus, virtual image it will be, virtual object it will be. But when you are going to keep object at focus plus F, then where will be the image? Image will be negative infinity. If you are slightly less than focus, so how will be the graph? Graph will be like this. Sorry. Like this. Like this should be our graph. Okay. I done correct only, no? Let me check. Okay. Plus F. So 1 by V equal to, sorry, 1 by F equal to 1 by V plus 1 by U. So U I am keeping slightly more than focus. Okay, and these are all positives because virtual it is. So 1 by f minus 1 by u equal to 1 by v. Okay, u is more than f, so v will be coming positive only. Should be correct. And here is slightly less than focus. Okay, u is slightly less than focus. So u is slightly less than focus means v will be coming negative. So it will be negative. That's fine. This for convex. Okay, so what I checked in this here, I checked it whether I have started it from correct end and here have I left at correct place. What I did is here this is u. Okay, here u is what, slightly more than focus here, slightly. So I checked that on. Say slightly more than focus. Okay, and this is positive. U is positive. This side here, no, this is origin. So this side positive. So here 1 by f minus 1 by u equal to 1 by v. Now since u is greater than f, this u is greater than f. So 1 by f minus 1 by greater than f, this will come positive. What positive? Infinity. So here is positive. So we have started correctly. That means this graph is correct. Then what about this graph? Starting is absolutely right. Minus infinity. Where is the focus? Where is the image? At positive f. So we started from here. Okay. Now this only I have to get. Now here what it is? Your object is slightly less than focus. Slightly less. So when this is slightly less than focus, then v value will come out to be negative. Now that means below. Fine. Now same thing let's make for concave. Okay. Concave here. Okay. Right. This is one. And this is the other one. Okay, this is u and this is v. Now concave's focal length used to be negative, so u will be negative f and v will also be negative. So those two we have to make now, those two lines. So negative f, let's make it here, and one more negative f is required, which will be below here. Okay, so this is for negative f in u and this is for negative f in v. So object is we are keeping at negative infinity. Then where will be the image formed? Minus f. Object at negative infinity, image is at negative f. Where we can say this is your u. So object is at negative infinity. Image will form at negative f. So that means here. Or we can take from here. Correct. So here will be the graph like this. In this itself. It will be like this. It will trim like this. Why? Because you will be going to object, you will be taking at minus f. So where will be image forming? Minus infinity. Now then, next one, from where we will start? We will start from here. Okay. When object will be at optical center, image will also form at optical center. Okay. Then, if you are going to keep the object at infinity, positive infinity, image will be forming at negative f. So it will be like this. This is for concave. So always remember how to make it. Again, shortcut I am telling you. First make these type of lines for positive f, positive f. Then, okay, then you think about which one is the smaller kind of, you say, 4 quadrants are there, no? Find out which are the smaller quadrants. So this is smaller quadrant, this is smaller quadrant. Same way here also, this is smaller and this is smaller. These are big quadrants. Because in that one, this extra f line is not there. Okay, wherever extra f line is there, that means those are smaller quadrants. So that means we have to start with the smaller quadrant. So what we have to see in this one? Now in this one here, negative infinity is this side. So don't go there. Okay, think about this one. That if, because this is smaller and this is smaller quadrant. So either this will be there first or this will be there first. Correct. So now we have to see that when you are starting from here, this is u is equal to more than f. U is f or slightly more than f. So where will be the image? Image will be forming at positive infinity. That's what we found here. What we were checking? U is slightly more than F. So V is it coming at positive. So positive infinity. So I made it immediately like this. Within this quadrant itself, this is not crossing the quadrant. Then second one is obviously starting from here, minus U at positive F. Then you directly join it because one is starting from here, other one will finish here. This is at positive infinity, this is the negative. Same way this one here. Here how we are starting? Minus infinity, image is at minus F. So this point. From here we are starting, so it will go like this. Smaller quadrant. The other one will. This we have to remember, these are shortcuts. Okay, 3 points we have to remember always. Where is minus U? Okay, U is minus infinity, where is the image? Optical center, it will be in optical center only. When object is at slightly before focus, where it is at positive infinity or negative infinity. If you can get it, then immediately this is ready. Okay, if you can make this one directly, then you know that other one is this. Same way here also, same. So 3 points if we can make, okay, we can get it. What are those points? U is minus infinity, U is 0, and U is minus F. Okay, U is minus F for concave mirror. In this one, U is negative infinity, U is 0, and U is positive F. If you can do these 3 points, then you will be getting the answer. Okay, U is positive F also. Remember in this one also there is a catch. What? U is slightly less than positive F. U is slightly more than positive F. Now 4 points I have said. Here also. So 4 points if you can see, you can clearly match without any problem. So these are the graphs. Okay. Relation between velocity of object and velocity of image. Okay. First we talk about plane mirrors. In plane mirror what we got a relation between object distance and image distance. From there only we are going to get relation between velocity also. So what it was in plane mirror, if this is plane mirror and this is principal axis, then we know that whatever is the object distance, same is the image distance. Okay, so position of object with respect to mirror is equal to position of image with respect to mirror. If we associate sign convention, then we know that this is positive and this is negative. So we can write like this. Position of object with respect to mirror is equal to negative of position of image with respect to mirror. We differentiate that. So we get what? Velocity of object with respect to mirror. Make it vector equal to negative of velocity of image. This we have to remember whenever we talk about plane mirror. Normally again velocity questions are not asked. So that's why we are not go into the solving this one, but at least we should know what the formula is. Okay, this for plane mirror. Now for curved mirrors, so curved mirrors we have mirror formula 1 by f equal to 1 by v plus 1 by u, which gives us relation between object and image distances from the pole of the mirror. So we'll differentiate this. Okay. So when we differentiate this one, we get this as 0. Okay. Then differentiating. Okay. Differentiating with respect to v or u anything, because v and u keeps on changing. So this is 0 minus 1 by v square. Okay, it's differentiation here, minus 1 by u square du by dv. Okay, so what we are getting, say this will be taking here 1 by v square minus 1 by u square du by dv. So this gives us minus u square by v square equal to du by d. Okay, now what we are going to do here? I am going to do inverse of that. That is dv by du equal to minus v square by u square. Now after that, I am writing this as dv by dt and I am writing this as du by dv by dt by du by dt. Now dv by dt is rate of change of position of image. Du by dt is rate of change of position of object. That is velocities. So velocity of image with respect to mirror by velocity of object with respect to mirror is actually equal to minus v square by u. Okay, this is the formula. Again, not many questions I have seen on this one, so remember the formula. If at all it is asked, we'll use it. Okay, this is velocity of object in image. Now, reflection due to combination of mirrors, that means deviation produced due to combination of mirrors. Which one? Plane mirrors. Okay, so what that is, what we have to remember in this. This is plane mirror number 1, plane mirror number 2, this is theta. Okay, a ray is coming like this, there is normal here, then from the normal it is striking and going, something like this it is, little more it is. Okay, something like this, then again one more reflection here, this is normal, then it goes something like this. Okay, so what we have to find is, we have to find deviation. How much deviation is created in the path, right? So if suppose we say this angle is alpha, and we know this is also alpha, this is beta, and this is also beta. Correct or not? Right. Now, individually if we see how much is the deviation created in the path of the ray, how much is the total deviation created? Now, the ray was coming like this, okay, it was coming in this way, okay, but because of reflection now is going like this, so this is deviation actually, this we call as delta 1 deviation, and here also the same thing is happening, here it was coming like this, okay, like this it was coming, now it's going in this way, so this is delta 2. So we have to add this delta 1 and delta 2, that is only the net deviation. So delta net is equal to delta 1 plus delta 2. Okay, so delta 1 is actually what? You can see that this total angle, this is 180. So delta 1 is actually 180 minus 2 alpha. You write 180 minus 2 alpha. That means deviation actually is 180 minus 2 times angle of incidence. What is delta? Delta is 180 minus 2 times angle of incidence. So here also it will be 180 minus 2 beta. But what we have to check over here, this is anti-clockwise. I said yes. This is also anti-clockwise. So we can add both. So this is 180 minus 2 beta. That means I am getting here 360 minus 2 alpha plus 2 beta. Okay, now what is this 2 alpha and 2 beta? You have to check that one. Okay, see this triangle? This is beta. So can I say this is 90 minus beta? So yes, we can say. And this is alpha, then this will be 90 minus alpha. So we can say over here this theta plus 90 minus alpha plus 90 minus beta equal to 180. That absolutely. So 90 plus 90, 180, and this is 180 is cancelled. So theta actually is alpha plus beta. Theta is alpha plus beta, that means this is actually 360 minus 2 theta. So net deviation is 360 minus 2 theta. Okay, net deviation is 360 minus 2 theta. Clear? Okay, clockwise, anti-clockwise, 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 both anti-clockwise. Or you can say 2 theta clockwise, both are same. 2 theta clockwise. So we don't have to do this. What is the angle of incidence? What is the angle here? Nothing is required. Okay, 360 minus 2 theta directly or 2 theta clockwise. How to determine whether it's 2 theta clockwise or 360 minus 2 theta? Because both are answers. Either of them can be in the option. So you have to choose it. So when 2 theta, how to find? So see it here. If this is the first mirror and this is the second mirror on which the light is going. Okay, so first mirror is like this, my hand. Okay, then it is coming to second mirror. How my hand is going to rotate? Clockwise. It's going to rotate clockwise. So my answer is 2 theta clockwise. If 2 theta clockwise is there, that means 360 minus 2 theta will be anti-clockwise. But if suppose that ray would have come like this, first is this and then this is there. So first mirror is like this, second mirror like this. So it will be going anti-clockwise. So my answer would have been 2 theta anti-clockwise or 360 minus 2 theta clockwise. That you have to take care. So however this is given, 2 mirrors, this, that, the answer will be depending on what is the angle between 2 mirrors and not what is the angle of incidence. Okay. So this is reflection due to combination of plane mirrors. Okay. So for today we are finishing here. Okay, mirrors, mostly reflection we have finished. In tomorrow's class we will talk about refraction and we will try to finish refraction through plane surface, refraction through curved surface. Okay. So alright students then, see you tomorrow. Bye bye.
Thank you, sir.
Wait a second, you have to take the